All right. Hey, Paulo. Update. As Morten, of course, have told you, we've started up on this little crazy CNC project. As this one is, well, it came to a full stop as the threaded rod we bought was bended. So, and we couldn't get the use the steppers we bought. We couldn't get them to work and all that. So, but yeah, I started this new project up. It kind of started because I got this from one of my friends, one of my colleagues, an old German guy. He got it from automotive industry. I think it was something that could, for some robot to pick and place something, it was easier than the material that it was picking and placing. When it had a little variation in the size, it was just easier to move this where it picked it up than it was to reprogram or change it in the program for the factory worker that made this machine run. But anyways, it's with a proper THK linear slides. It only has about 100 mil of travel, not about, it has exactly 100 mil of travel. So the Y-axis, as this is only 100 mil in travel. It's very heavy duty. This whole frame here, where you can see the bolts going through, is very thick, 30 mil thick cast iron. Here at the lowest point, these points here are, of course, they're fucking 50 mil, I think. But very, very heavy, very sturdy. It's bolted to this base plate. Base plate is 15 millimeters thick. Some kind of steel. It, as you can see, it's been laser cut somewhere in some factory. Everything is from the scrapyard except for the THK rail, the Y-axis sitting on. That I got from the friend, of course. But it's bolted through with some big bolts, 4 of them, up through the base plate. I could add more, but I don't think it's going to be necessary, as it's really sturdy, sitting flat on this big heavy plate. These bearings I got also from the scrapyard. There's a lot more bearings. I have a whole box full. It was not a full pallet, but a half pallet full of bearings I bought for 300 crowns. So yeah, already there, my money is home safe. I found this shell-hardened ground steel, 25 mil, of course, so it fits the bearing, but at 2 different scrapyards. So that's just, I don't know, lucky. But this is really smooth. There's no weird sounds or balls clicking or nothing. It's crazy smooth and crazy stable. I put the micrometer on the base plate and to this, and when we're all the way out, I can push it about 2.5 hundredths of a millimeter. It's not perfect, of course. If it was perfect, it would be moving absolutely nothing. But once the work surface, it's going to be put on these 2 blocks here, which is also going to be pretty heavy steel. So when you push down upon that, here where the work is being done, it'll try and move these 2 up. So I'm thinking that, or hoping that that it's going to halve it. It's going to halve the movement of it. The plan was to have the C-ax mount here. We were going to get some proper rails, the small square rails like the THKs. So we could get, as close to this before we started the C-ax, so we wouldn't end up too far out as we only have the 100 mil of travel. But then an unnamed person came up with a brilliant idea, because they are fairly expensive, 1,500 crowns that's plus with tax and shipping and everything for the THK rails that we wanted. Not THK though, but same style. But that was like 3 times as much as them other rails we have. That same supported rail type. So again, an unnamed person said, let's put them rails out here on the side, and then just have the CX plate just clear this, just clear it. And then a really brilliant person, as in me, decided that I'll just mill like a slot here in the middle, and then we'll put the ball screw on the back. So the ball screw is sitting behind this 20 mil aluminum plate, and then with it's connected with a piece of thick aluminum through to the C-ax, so it will move that up and down. That's a really good idea. But I had these big M10 bolts sitting through this is also 15 mil, and it goes very far into this aluminum plate, as aluminum is not the best material to make a thread in and to put a lot of torque on. So I made a long thread. It's about 30 millimeters into this plate, so we have a lot of thread to grab onto. But they're going to be in the way of the new rails. So I don't know what you call that, countersinking or whatever. But they're flush with the steel plate now. Downside is that the little play you would have in a hole like this, it's an M10 bolt. So I drilled a 10.5 to have 0.25 millimeters of clearance all the way around, so I could move the plate in or out, so it would be a better angle. If it was off ever so slightly, I could adjust it in the hole and tighten it down. But as these bolts have this, they look like that. So that whole angle bit here is of course gonna steer the whole plate. So all the holes have to be really exact. As it turns out, they're actually quite alright. So I don't think we're gonna have any problems. But like I said, we haven't, well, maybe I didn't say that, but we haven't adjusted anything yet. We haven't aligned anything yet. And this is a very good quality angle. It's just resting on the bearing. And look, when I move the Y-ax into position, I don't know if you can see that, but that is very, very close to being 100% in angle, 90-degree angle on the Y-ax, on the X-ax bearings. So, but I think it was a really good idea to put these large steel plates on. I don't know how long they are actually. Yeah, 215 millimeters across. That's gonna be so sturdy, you wouldn't believe. And they are also drilled through the base plate with some M8s, 5 M8s up through the base plate in both of them. So yeah, that's it. Progress so far. These are for the NEMA 23s, and I don't know if Morten already told you, but we bought some NEMA 23s with separate stepper drives and a breakout board, and they are weight-wise twice the weight of yours. So we are expecting them to be pretty powerful. They are about 100 mil long, so about this far out. I made some bearing supports, or some bearing holes here for the bearings to hold the the Y-ax ball screw, which also have been ordered. So that's very nice.